Good day and welcome to Space Station Live for Wednesday, August 7th, 2013. You're inside the International Space Station Flight Control Room at the Johnson Space Center in Houston, where at this hour the Orbit 2 team of flight controllers is on duty overseeing the work of the Expedition 36 crew on board the orbital outpost. At this hour, the Orbit 2 team is led by Flight Director Richard Jones, who is presiding over the daytime shift, if you will, the second half of the crew's workday that began just after 1 a.m. Central Time with their typical daily wake-up call from Mission Control to begin another day of research activities on board the orbital outpost. The Expedition 36 crew, comprised of two trios of crew members who arrived on the station at different times, Alexander Mazurkin, Pavel Vinogradov, the current station commander, and NASA flight engineer Chris Cassidy, who launched to the space station aboard the Soyuz TMA-08M spacecraft on March 29th on the first Soyuz single-day launch to docking activity that took place, expediting their arrival on the International Space Station. They were joined 2 months later by the second trio of crew members currently on orbit, flight engineer Karen Nyberg, Russian cosmonaut Fyodor Yurchikhin, and European Space Agency flight engineer Luca Parmitano, who launched on the Soyuz TMA-09M spacecraft on May 29th in a single-day expedited rendezvous with the International Space Station to join the other three. The 6 crew members continuing to work in tandem with one another on a variety of activities, including research and preparations for the arrival of a new cargo ship later in the week. The Expedition 36 crew has been involved in a variety of experiments today and research activities, including one called the ACE experiment, the Advanced Colloids experiment, the first in a series of microscopic imaging investigations of materials to determine how better to formulate materials in the microgravity environment of space. Astronaut Karen Nyberg, her gloved hands inside the microgravity science glove box earlier today, had an opportunity to prepare for the next run of data collection with the Advanced Colloids experiment, again in the microgravity science glove box in the Destiny Laboratory of the International Space Station, just one of a variety of experiments being conducted on board the International Space Station. Meanwhile, Russian cosmonauts Fyodor Yurchikhin and Alexander Mazurkin were busy in the Russian segment of the complex preparing their Orlan spacesuits for 2 spacewalks coming up on August 16th and August 22nd. The first of those 2 spacewalks to be conducted outside of the Pirs docking compartment by Yurchikhin and Mazurkin will install a panel of experiments on the Poisk module, deploy a gap spanner between the Zarya module and Poisk, and to install Ethernet cables on the Poisk module that will be part of the hardware associated with the arrival of a new Russian laboratory module at the end of the year. 6 days later, they'll venture back outside the Pirs docking compartment on August 22nd for another spacewalk in which they will trade out a laser experiment on the outside of the Russian segment of the space station for a pointing platform upon which an optical telescope will be launched in the near future. The Japanese cargo ship, the H-2 Transfer Vehicle, or the HTV-4, continues to fly smoothly toward the International Space Station, having conducted a series of rendezvous maneuvers again throughout the past 24 hours. As of a few minutes ago, the HTV was traveling just under 5,000 statute miles behind the International Space Station, some 70 statute miles below the complex, phasing back toward the International Space Station at a rate of about 770 statute miles per orbit. The HTV is poised to be captured by astronauts Karen Nyberg and Chris Cassidy using the station's robotic arm on Friday morning, the capture scheduled at 6:29 a.m. Central Time. Cassidy and Nyberg are also working inside the Japanese Kibo module, preparing a series of satellites called SPHERES, the acronym for the Synchronized Position, Hold, Engage, Reorient, and Experimental Satellites, for some test runs that will be conducted in an ongoing competition with students that will be gathered next Tuesday at the Massachusetts Institute of Technology, where the experiment's principal investigators are housed. The SPHERES experiments enable students to engage in a competition in which they program the satellites to gather data on the operation of free-flying satellites in a microgravity environment. And that's a glimpse of what's taking place today aboard the International Space Station.
And Chris, we can confirm what you said about Sasha. And just one quick question on the previous two items that you did not transfer. Where are they stowed?
They're in their home spots in the airlock, in the original bags.
Got it. Thank you.
This view of Karen Nyberg and Chris Cassidy inside the Japanese Kibo laboratory as they prepare for a dry run for the SPHERES experiment competition that will take place next Tuesday. The Zero Robotics competition to be originated out of MIT, again, is a student competition developed and led by researchers at the Massachusetts Institute of Technology. During a 5-week summer program, middle school students learn to program these satellites through a graphical interface. It's a very unique test session. This involves elementary and middle school students representing schools out of Florida, Georgia, Idaho, and Massachusetts. Again, that competition actually will take place next Tuesday, originating from MIT.
Station, this is Spears on Space Ground 3 for Kristen.
Yeah, hey, Eric, this is Chris and Karen. Nice to be working with you today.
Good morning, how are you?
Wonderful. Where in the world are you? Boston or California or Huntsville?
I am here with the Spears team at Ames in California, and I've got MIT in Boston in my right ear, so we got a whole team here for you and Karen today.
All right. Well, we're happy to be working with you, and we've read all the read-ahead messages. And one thing we weren't sure of, this is just a test for the actual competition, right? Or this is not the actual competition.
That is correct, Chris. This is a dry run for the middle school Zero Robotics event happening on the 13th on GMT 225.
Copy that. All right. Well, we're happy to be doing it, and here we go. Powering on the SPHERES.
Okay, and Chris, before we get going, two things I wanted to communicate you. The first, if we could, the ELC on the forward side, right in front of Karen. If we could move that off to the side, that would be great. That's something we could have better communicated to you.
Okay, you're talking about this one right here, right?
Correct. And the second comment I wanted to pass on, just to give you a heads up, we're only interested in attempting to complete 6 of the runs today, and we will be starting with the Bravo run. and that is, of course, after the quick checkout.
Okay, so we'll do the checkout, and then we'll do 6 runs in Bravo, and have the ELC move. Sorry about that. I gave bad knowledge here to Karen. I was thinking that you wanted that screen in the field of view, but it's off to the side. Just let us know if any other things you want. We're happy to move it.
Great, thank you, Chris. Yeah, and that screen position, like I said, was probably an error on this end that we should have communicated, so I appreciate you moving that over. And just to clarify, after the quick checkout, we will be starting with Run Bravo and then moving on to Charlie, and a total of 6 runs we're looking at today. And I'll let you know as we go along what the next run will be.
Okay, we are following along with you on the test plan, starting in line Bravo and going up to Golf, I guess. That counts up to 6, I think.
Well, we will first do the quick checkout, and the first run after the checkout will be Bravo, and then Charlie, and we'll be skipping some runs as we go, and I'll keep you informed ahead of time.
Okay, that sounds good.
And welcome back with us inside the International Space Station Flight Control Room. As you've been watching, Karen Nyberg and Chris Cassidy have been working with the Spheres satellites on a dry run for competition with students at MIT next week. A different sort of satellite is closing in on the International Space Station in the form of a Japanese cargo ship called the H-2 Transfer Vehicle, or the HTV-4, a big cargo ship due to arrive on Friday morning. And with us today here in the ISS Flight Control Room to talk a little bit about HTV, its operation and upcoming activities, is the NASA lead flight director for HTV-4, Ed Van Cise. Ed, thanks for joining us.
Good morning, and very excited to be here. And we've been working on HTV-4 since HTV-3 departed just about a year ago, so it's very exciting to be this close to being able to reach out and grab it on Friday.
Ed, launch on Saturday was flawless. Can you give us sort of a synopsis of the last several days of activities and preparations by the crew on board between now and Friday for the capture of the spacecraft?
Absolutely. Like you said, it was a flawless launch, and the vehicle is performing very well. It is a longer rendezvous profile than some folks might be used to when they've recently been watching things like Progresses, Soyuzes that are arriving in only 4 orbits, and then Dragon shows up just a day or two after launch. So it might seem a little out of place that HTV takes 6 or 7 days to arrive. Of course, we take advantage of that time frame. We do a lot of the crew training either the week before launch or even while HTV is on its way. So it's still fresh in the crew's mind. Just this week, we put them through their paces in flying the Canadarm2 to get them ready for capture. But as far as HTV itself, there have been a couple of very minor things that the team has been working through. One of them has to do with the latching valves, the propulsion system on one of the strings of its propulsion system, and basically what that is a sensor issue that they've seen very sporadically and not very often, where it'll indicate one position where the valve is physically in a different position, open versus closed. So it's actually been a good test of the integrated training that we've done to get ready for this mission. We go through a lot of different simulated cases on being ready to handle situations like this. The Japanese team has done a very good job investigating what might be wrong and coming up with workarounds. And in fact, right before this interview, we just finished a meeting this morning to make sure we had a good plan in place for Rendezvous Day. So if you hear us on Rendezvous and Approach talking about the prop system a little bit more than what you might otherwise have expected, that's just because we want to make sure we have all the right checks and things in place in case the next failure happens. And that's what we always worry about is, and we focus our training on, is okay, the system is designed to handle one problem such as this, and we want to make sure we're ready for that second problem. All that to say, though, that the vehicle is very robust and it's very performing very well in its flight. It's been doing a whole bunch of rendezvous burns to get us to this point to show up on Friday for the ISS.
I think our viewers would be interested in finding out why the 6 days. And it could be 2, it could be 7, it could be longer. Why was 6 days for this rendezvous chosen?
Right. So the unique thing about HTV and some of our other vehicles is that the vehicle has the capability to launch pretty much at any time as long as the orbit path is flying overhead of the launch site. So instead of, let's say, for example, the Progress or the Soyuz 4 orbit rendezvous, not only does the orbit path have to be over the launch site, but the ISS has to be in a very specific place so that that shortened rendezvous can occur, and all the timing works out. With HTV, it has the capability to do a wide variety of maneuvers on orbit, both changing its orbital plane and then also changing its altitude, of course. And that capability allows it to launch pretty much at any point, and we call it phasing, with respect to ISS. So we don't require the space station to be at a certain point in the orbit. But when you set something up like that, you go from a trajectory that has just a small number of very large burns to get you to that final destination, to a trajectory that has a lot more smaller magnitude burns. And so that's why you're seeing a 6-day rendezvous in this case. And before we locked in the final launch time for last Saturday's launch, we could have actually launched on Saturday or Sunday and still rendezvoused for a Friday capture. But once we picked the exact launch time, then it was set up to be a very specific Friday capture. So yes, it's a longer profile, but it actually provides a lot of flexibility for the space station program to be able to do the launch and the capture operations.
And one of our social media questions that we received from @IrishSpaceblog actually asks, why did the HTV actually lap the International Space Station? It's all about Johannes Kepler, I guess.
Yeah, exactly right. It all has to come back to the phasing, and because of when we launched and the altitude of HTV relative to ISS. The lower you are, the faster you go, and thus HTV went around and did a lap around us. And that all is being set up so that on actually it'll be late Thursday night here in Houston. HTV will show up on the same velocity vector, same altitude as the space station, just a few kilometers behind us, and then we'll go into what we call integrated operations, where it'll make its big maneuvers to come up underneath us on the R bar, if you will, and it'll look very similar to what the shuttle did when it did its rendezvous profile, except HTV will stop underneath ISS instead of going out in front like space station or like the space shuttle did.
And on Friday morning, it'll come up from underneath the space station, and the cupola will be a very busy venue with Cassidy and Nyberg, along with Luca Parmitano, monitoring systems and operating the robot arm. How cramped will all of that be, and how carefully choreographed is all of that activity to reach out and actually grapple the spacecraft and then carefully install it onto the Harmony node?
Yeah, the cupola, everybody's favorite place to be on the space station, and then I know everybody has seen pictures of what it's like inside, and like you said, it's a small place. They do train, of course, here in Houston to do these operations in mock-ups of the cupola, but nothing beats doing it in the real thing. So these last couple of weeks, we have been doing training in the cupola to make sure they understood where their body placement will be for best having access to the different pieces, parts of this orchestra. Really, there are 3 separate roles that all these crew members are playing, and so you've got Karen, who's got to fly the robot arm, and so she needs to be in a certain place. You've got Chris, who's helping her monitoring the robotic system, so he needs to be able to see that information, and then Luca will also be monitoring the HTV systems, and there's a separate command panel to send commands to the HTV, so he needs to be positioned to be able to take care of that. So having that all laid out in the cupola and doing real training in the real vehicle this week has been really influential in making sure everybody knows where to be and get the job done.
Well, Ed, appreciate your insight, and we'll look forward to working with you on Friday morning. We'll have live coverage twice on Friday morning, starting at 5 a.m. Central Time, 6 Eastern, of the rendezvous and grapple of the HTV-4. We'll come back on the air at 8 a.m. Central Time, 9 a.m. Eastern Time for the actual installation work that will take almost 2 hours to complete, and we're looking forward to that and the arrival of a new ship at the International Space Station. Thanks very much, Ed.
Thank you.
We partially borrowed equipment from Chris.
I just want to make sure we're not doing something wrong, and we did the right button pushes in the right order that time.
For the checkout, Karen, there are no button pushes on the keyboard, if that's what you're referring to.
I was just talking about the order of the of running the test as far as enabling and all that, but we'll just follow the procedure again and hopefully get the right answer.
Yeah, everything looks good from this end. Sometimes they just need a little waking up.
Sounds good.
This is Mission Control Houston. Once again, inside the Kibo laboratory of the International Space Station, Chris Cassidy, with his back to the camera, working with Karen Nyberg as they set up the equipment for a dry run of the Spheres experiment. Again, the acronym for Synchronized Position, Hold, Engage, Reorient Experimental Satellites. This is all part of the preparation for a competition called the Zero robotics competition with students that will be gathered at MIT next Tuesday, part of an ongoing series of competitions in which the students not only program the satellites, but then engage in a competition interacting with the crew on board the International Space Station. Only a part of the myriad of research that takes place aboard the orbital laboratory at the Marshall Space Flight Center at the Payload Operations and Integration Center in Huntsville, Alabama. We'll be joining Laurie Meggs a few minutes from now to talk about other investigations that are ongoing aboard the orbital outpost. Again, our update on scientific research from the Marshall Space Flight Center coming up in about 4 minutes on Space Station Live.
Eric, on that quick checkout, we got a value of 1 for each blue and orange.
Excellent, Karen. We got a happy team here. Thank you.
Right behind Karen Nyberg, you see that circular hatch. That is the hatchway to the Japanese Experiment Module, or GEM, airlock, beyond which is the experiment platform called the Exposed Facility. That is essentially the forward porch on the Kibo module, which is the Japanese Experiment Laboratory of the International Space Station. It is to that exposed facility that a number of experiments and an exposed pallet will be attached robotically that is being carried to the International Space Station as part of the more than 3.5 tons of cargo on the H-2 transfer vehicle that will arrive at the complex on Friday morning.
Yes, Karen, and just to make sure, we are going to be going to test run Bravo.
Okay, I think that's number 3 on the list, correct?
That is correct, and just to also reiterate that you will be doing key presses for the rest of the runs, as indicated in the comments section on the test plan.
Karen Nyberg and Chris Cassidy, once again, are the prime and backup robotics officers who will be stationed at the robotics workstation in the cupola of the International Space Station on Friday morning, monitoring the slow, methodical approach of the H-2 transfer vehicle up from a position directly underneath the station to a point about 35 feet away from the station's robotic arm that will then be extended to grapple onto the HTV and reorient it for its berthing on the Earth-facing port of the Harmony module. HTV-4 will spend a month at the International Space Station. Its payloads and equipment to be unloaded before it is filled up with trash and then unberthed for its discarding and a fiery reentry and its demise over the Pacific Ocean with its unberthing schedule for September 4th.
Also help out after you press run on the GUI, that's when you'll be pressing the key 3 on the keyboard.
Here in the International Space Station Flight Control Room here at the Johnson Space Center, work continues as the Orbit 2 team watches over the activities of the Expedition 36 crew on the orbital outpost. Meanwhile, research is continuing and abounding aboard the laboratory, 260 statute miles above the Earth. Let's head out now to the Marshall Space Flight Center in Huntsville, Alabama, where Laurie Meggs is standing by at the Payload Operations Integration Center. Laurie, there's a lot of work going on, particularly with the fluid physics investigation.
That is right, Rob. Flight controllers here in the Payload Operations Integration Center, as well as the Microgravity Science Glove Box team down the hall here, have been working with Karen Nyberg as she conducts runs of InSpace 3. That's been happening over the past few weeks. Now, this is the third in a series of fluid physics experiments that studies the way colloidal particles behave in microgravity when influenced by a magnetic field. Now, this knowledge could lead to better designs of bridges and buildings to withstand earthquakes. I recently spoke with the principal investigator to find out more about InSpace 3.
InSpace studies colloidal particles and their organization, how they come together. We apply magnetic fields to the suspensions, these colloidal suspensions and fluid, and watch how they organize. And part of what we're trying to do is study how that organization happens over time scales, and then manipulate that.
What are colloidal particles, if people don't know?
That's a great question. Colloidal particles are tiny, about micrometer dimension particles. This is what colloid refers to as a length scale of matter. And so it's a unique length scale where particles have the ability to move around inherently, and that gives them a ability to self-organize or self-assemble. That's what makes them exciting and interesting for materials applications.
So how is how they react on the ground different from how they react on the space station?
Particular suspensions we study are sensitive to magnetic fields. That's one of the ways that we can organize their structure. We can put them in magnetic fields, and they can self-assemble because they become little tiny magnets, basically. Those unfortunately sediment pretty quickly under gravitational fields, so that limits the types of experiments that we can do. The ISS, the microgravity environment, allows us to study these particles over long times, hours, without having that effect of having them settle out to the bottom of our container.
So what have you learned so far? This is your third InSpace experiment?
We're currently
lots
running
of runs, right?
experiments called InSpace 3. The InSpace 2 experiments were published last year. We learned some phenomenal things about how particles self-assemble or self-organize, and in particular how we can guide that self-assembly. So the implications for us are how materials then organize into structures that are useful technologically, and they create new materials that we can use for energy applications, for display applications, advanced coatings for thermal barrier applications, etc.
So why is there a third one now?
There's a third one because InSpace 2, we wanted to start to change the building blocks, the colloidal particles that we're working with. So InSpace 2 had looked at particles that were spheres. What we did with InSpace 3 was we stretched those particles out into ellipsoids. We created these sort of rice-like shaped particles. And that anisotropy in shape, the fact that they're no longer spheres, confers a little bit different properties on them, and we think that that's going to have important implications in how they self-organize and the types of experiments that we've been doing.
And why is all of this important to us here on Earth?
It's important because this tells us how we can create new methods of manufacturing nanostructured and nanoscale materials. There's a real opportunity right now, given the sort of building blocks that we have available in terms of nanoparticles, these uniform particles that people can, synthesize. That's like little building blocks to build new structured materials out of. And we're trying to figure out the roles of that self-assembly, that self-organization, so that we can actually enable that. Those will create the materials that are behind our fascinating devices and technologies. They're not the ones that we see on a daily basis, but they underlie everything that we deal with sort of in our daily lives.
Now, for more information on this and other investigations, go to nasa.gov/station. And that'll do it for us from here in the Payload Operations Integration Center in Huntsville, Alabama. Now back to you, Rob, at Mission Control in Houston.
Thanks very much, Lori. Once again, just a variety of research ongoing aboard the International Space Station, the Payload Operations Integration Center at the Marshall Space Flight Center in Huntsville, Alabama, responsible for payload activities, working in concert with the flight control team here at the Johnson Space Center and other international flight control teams representing the other international partners on a global basis. Back inside the Kibo module, the Japanese laboratory, that is the Japanese hallmark of their segment of the International Space Station. As you watch Chris Cassidy and Karen Nyberg monitoring the systems on some of the free-flying satellites called the Spheres, for synchronized position, hold, engage, reorient experimental satellites. That is the acronym. This is an investigation out of the Massachusetts Institute of Technology. One of the principal investigators, former astronaut Jeff Hoffman.
33 for orange.
As Cassidy and Nyberg calibrate these satellites and put them through a dry run in advance of a student competition, basically a race between satellite teams out of MIT that will take place next Tuesday.
That was a great run, Chris and Karen. We couldn't have asked for anything better. Karen, you are officially a Spheres Pro now, and we will move on to test run Charlie in that first bracket, the next run.
One of the Spheres investigators congratulating Nyberg on her initial proficiency with these satellites. Chris Cassidy actually conducted one of these sessions back in May, so he's an old hand at this. Once again, the Zero Robotics competition to be conducted next Tuesday is a student competition developed and led by the Massachusetts Institute of Technology. During a 5-week summer program, middle school students learn to program these satellites through a graphical interface.
Start in the same position?
Karen, yes, they do. I was actually going to pass that on to you earlier. So the way Chris has them now, they can be for all the runs coming up. Excellent pickup.
Some of our brain cells.
And we also appreciate the viewing that you two have been giving us. We're getting some great video here, so we really appreciate your positioning.
The middle school teams that will be competing on Tuesday with the Spheres satellites include the Lewis Carroll Elementary School out of Merritt Island, Florida, near the Kennedy Space Center. The Ralph Williams Elementary School in Rockledge, Florida, also near the Kennedy Space Center. The Southern Oaks Middle School, just to the south at Port St. Lucie, Florida. The Salvation Army Boys and Girls Club of Metro Atlanta in Atlanta, Georgia. The South Junior High School in Boise, Idaho. A series of students representing the North Idaho STEM schools in Rathdrum, Idaho. And then 3 Massachusetts groups, the Malden YMCA out of Malden, Massachusetts, the Salem Cyberspace students out of Salem, Massachusetts, and the Timilty Middle School out of Boston. All of those groups will be competing next Tuesday, along with Cassidy and Nyberg in the next Zero Robotics competition. The goal is that the fastest team with the most fuel in the satellites at the end of the match is declared the winner.
Orange may have reset. We're going to do this run again.
Seven for blue and 255. So we'll do it again.
Thank you, Chris. Sounds good. We'll reset the satellites and give this another run.
Sorry, but did you say you wanted the satellites reset?
Yes, that is correct, Karen. We'll reset both satellites. And Karen and Chris, the positioning looks good right now. And just a note on orange, if we continue to having reset issues with orange, we'll keep our eye on the low battery indicator.
As we watch Chris Cassidy documenting the calibration and dry run of these Spheres satellites, once again, this is all designed as a basis for engaging students in an on-orbit competition in which they program and then have the crew control the satellites in a team competition, the next version of which will be conducted out of MIT with the participating groups of middle school students at MIT next Tuesday. The Spheres Zero Robotics develops and builds engineering skills for students, including such things as problem solving, the process of designing systems for such satellites, training in the operation of a satellite, teamwork, and the presentation skills associated with all of that activity.
Karen, orange and blue are doing what they're supposed to be doing. And Chris and Karen, the run is looking good. The satellites are going to their finished positions within the race. Things are looking good.
Okay, the
Blue
result
is coming up to orange.
We have blue 23, orange 51.
Blue 23, orange 51. Spheres copies. Thank you. We will move on to run echo in bracket 2, run echo.
The crew, Cassidy and Nyberg, working with the calibration in this dry run of the Spheres satellites, testing fuel levels, also the algorithms that are programmed into the satellites to make sure that they operate properly. Essentially, the crew next Tuesday will be manning those satellites, and as the teams on the ground at MIT work with the satellites on a remote basis, those satellites will actually take off in a race down the length of the Kibo module. The satellites that wind up reaching the so-called finish line first with the most amount of fuel are declared the winner.
We have an orange lost comm. Would you like us to stop it? It stopped itself.
Yes, Chris, we'll reset orange. What kind of battery readings are you getting on orange?
Let's see. We just see a green battery, but no percentage number or anything, just a green dot.
Great, thanks, Chris, for that feedback. And Karen, during the run, if you can just watch the battery indicator on the GUI, just watch for green or red, orange, green or orange during the run to see if it stays either of those colors in the run. That'll be good feedback for us.
I'll take a look at it while it's running.
The GUI that is referenced there in that conversation between the investigators on the ground, Force Spheres and Karen Nyberg, is an acronym for Graphical User Interface. It's essentially a program on one of the laptop computers that the crew is referencing in the Kibo module that provides information regarding the operation of the satellites and their individual fuel levels.
It's in the green now. We had another stop of it.
Sears copies, Karen. Stand by for a moment, please. Station Sears for Karen and Chris. We're going to do a power cycle on orange. So if you can turn orange off, give it about 30 seconds to a minute wait, and we'll power it back on and see how things look.
Cassidy and Nyberg, you're looking at the two robotics officers for the capture of the Japanese HTV-4 cargo ship come Friday morning as it approaches the International Space Station. Chris Cassidy currently in his 132nd day in space since his launch, with Pavel Vinogradov, the current station commander, and Alexander Mazurkin in their Soyuz TMA-08M spacecraft from the Baikonur Cosmodrome in Kazakhstan back on March 29th. That trio will be returning to Earth on September 11th, Kazakhstan time, the night of September 10th U.S. time to wrap up their 5.5 months in space. Karen Nyberg, meanwhile, arrived on board the International Space Station 2 months later on May 29th, along with Fyodor Yurchikhin and Luca Parmitano of the European Space Agency. They are in their 71st day in space since their launch back on May 29th in the Soyuz TMA-09M spacecraft. They'll be returning to Earth for a landing, a parachute-assisted landing on the steppe of Kazakhstan on November 11th, Kazakhstan time, the night of November 10th, U.S. time. As we have mentioned throughout the course of this broadcast, the Japanese H-2 transfer vehicle, the HTV-4, continues to fly smoothly on toward the International Space Station. No significant issues being worked by the flight control team here in Houston or the Japanese flight control team for the Japan Aerospace Exploration Agency based in Tsukuba, Japan. The HTV-4 is about to enter the most critical 48 hours of its operations with a number of key rendezvous burns through its reaction control system jets to increase its altitude to match the altitude of the International Space Station, and then to close in for its the terminal phase of its rendezvous on Friday morning. We will have 2 broadcasts on Friday of HTV-4 activities. We'll begin at 5 a.m. Central Time, 6 a.m. Eastern Time, with our coverage of the terminal phase of rendezvous and the grapple of the HTV-4 by Nyberg and Cassidy, who will be operating the Canadarm2 robotic arm from a robotics workstation in the cupola of the International Space Station. The actual grapple is scheduled for 6:29 a.m. Central Time. That grapple time is calculated to be about 34 minutes after sunrise and about 34 minutes before sunset, basically at orbital noon, as the HTV and the space station fly in tandem some 260 statute miles above the Earth. We'll take a break at that point, as will the crew, until 8 o'clock Central Time on Friday morning, 9 Eastern. We'll be back on the air with berthing coverage as the robotics officers, Nyberg and Cassidy, carefully maneuver the HTV-4 and begin to move it towards the common berthing mechanism on the Earth-facing side of the Harmony node of the International Space Station, as depicted in this animation.
55 for Blue Room.
The passive common berthing mechanism on the HTV will be precisely aligned with the common berthing mechanism, which is the active CBM, as it is called, on the Earth-facing side of Harmony. It will slip into the capture envelope. Ready-to-latch indications will be noted by the crew on board the International Space Station, and once in place, then will be bolted to the common berthing mechanism in a 2-stage fashion to become a permanent fixture for the station for the next month before it is unberthed on September 4th and sent into a deorbit burn the following day to burn up over the Pacific Ocean. It will be loaded with trash at that point. Again, our coverage begins at 5 a.m. Central Time, 6 a.m. Eastern Time on Friday morning, as HTV-4 comes into the vicinity of the International Space Station for its grapple and its berthing to the Earth-facing side of the Harmony module. As we watch Nyberg and Cassidy monitor the orbital dance of 2 of the Spheres satellites inside the Kibo module in this dry run in advance of a student competition with the satellites next Tuesday, we also might remind you that once HTV-4 becomes part of the station on Friday, its hatch is scheduled to be opened on Saturday, and then on Sunday, robotics officers here in Mission Control will be working in tandem with Japanese robotics officers at Tsukuba, Japan, to extract a pallet of experiments from a slot on the side of the HTV-4 The Canadarm2 will be used to initially extract that pallet of spare parts that are housed inside the side of the HTV vehicle. They then will maneuver it for a handoff to the Japanese robotic arm, the GEM RMS, or Remote Manipulator System as it is called, at which point it will be mated to the exposed facility, which is the front porch, if you will, on the front of the Kibo module of the International Space Station. And then next week, one by one, experiments will be plucked off and installed not only on the exposed facility, but also on various locations on the truss of the International Space Station to be used if required at a later date. And a great close-up view from one of the cameras inside Kibo as Chris Cassidy documents the operation of these Spheres satellites in this dry run in advance of the student competition planned for next Tuesday, based out of the Massachusetts Institute of Technology. With that, we will bring our broadcast to a close with a couple of programming notes. Coming up on NASA television at the top of the hour at 11 a.m. Central Time, noon Eastern Time, the NASA television video file, a compilation of all of the key video of activities taking place throughout the agency, in addition to all of the work aboard the International Space Station. We'll be back on the air with Space Station Live on Thursday at 10 a.m. Central Time, 11 a.m. Eastern Time with our next broadcast, and we will remind you, you can follow all the activities on the International Space Station on our website at www.nasa.gov. At a mission elapsed time of 132 days into Expedition 36, this is Mission Control Houston.